Hi everyone, welcome to the video. In this video, under the subject Database Management System, I'll be discussing on the topics granularity, multiple granularity, and the limitations of it, intention mode locks to overcome the limitations. Granularity is the size of the data that is allowed to be locked. This locking technique allows locking of various data sizes and the sets. This way of breaking the data into blocks that can be locked decreases lock overhead and increases the concurrency in the database. Multiple granularity helps to maintain the track of the data which is locked as well as the data as well as how the data is locked. Granularity in DBMS. Transactions in the databases are atomic, which means when a transaction needs to access the values in the database, a locking protocol is used to lock the database. Locking prevents other transaction from modifying or viewing the database simultaneously because other ongoing transactions are locked. It is very important to lock the database while performing a transaction optimally. Locking an entire database unnecessarily can cause loss of concurrency. Let's understand the concept of multi-granularity with the example of tree. Here there are four levels, that is database, area, file and record. The first level of the tree, that is root, is the database which contains several tables as well as the records. And the next level is the area, which is the child nodes of the which are the child nodes of the database. And then the file, which comes in the next level of the area, and the last level of is the contains the records. Records are the child nodes of the file and cannot be present in more than one file. There are two problems in this approach, like the limitations are if we want to apply a lock on a node, we have to ensure that no ancestor of the node is locked. That is, if we have to lock any of the child nodes here, any either from the records, files, or area, if we, for example, if we are considering to lock this file FA, we have to check that the area is not locked as well as the database should not be locked. So if we have to lock any of the node here, the ancestor node has to be checked. That is, the ancestor node should not be locked. And the second limitation here is to acquire a lock on the entire database. Here, if we want to lock the entire database, we have to check through each node that whether it is locked or not. If any of the child node is locked, then the database cannot be locked. So if we want to lock the database, each node has to be checked. If they are not locked, at that time we can lock the database. So these are the two limitations. That is, if we want to apply any lock on these child nodes or any node, the ancestor nodes should not be locked. And if we have to lock the database, the child nodes, all the further nodes should not be locked. So the approach that how we can solve the limitations are, we can have a shared lock or the exclusive lock. In shared lock, the shared lock are used while reading data only, and lock prevents other transactions from updating the data but allows them to read the data. In shared lock, it is applied like only it is applied only while reading the data. And this prevents other transactions from updating the data, but it will allow to read the data. Exclusive lock. When the data is being modified, exclusive lock prevent other transaction from reading or modifying the data. Now, any of the data is being modified, these if these exclusive locks are implemented there, they will prevent all the other transactions for reading or modifying of the data. And the different types of intention mode locks are intention shared lock, intention exclusive lock, and the last one is shared and intention exclusive lock. Intention shared lock. If there is an intention shared locked on a node, then the lower level tree only has explicit locking with the shared lock. That is, when a node have an intention shared lock, or the node can have intention shared lock only when the nodes at the lower level of it are having shared lock. So in shared lock, as we know, we can only read the data. The next one is intention exclusive lock. Explicit lock on the lower level tree from the node with either shared or exclusive lock. So the lower level nodes are locked either with the exclusive lock or the shared lock. So that is intention exclusive lock. And the next one is shared and intention exclusive lock. In shared and intention exclusive lock, the subtree of the locked node is explicitly locked in shared mode and with an exclusive mode lock at the lower level. So if you are implementing a shared and intention exclusive lock, the subtree will be locked with the shared and the lower nodes of it will be locked with the exclusive mode lock. So this was all about the video. Hope you all liked it. Thank you.